preserving and curing content, and pectin's got a lot of different food applications. Then thinking of preserving and curing, obviously we're thinking about jams and jellies in particular. So what is pectin? Pectin is a polysaccharide gum, so it's providing a high viscosity texture in food products. Jams and jellies being one of the primary uses, but we'll talk about some other uses in foods. Pectin itself is the cell wall glue that sticks together the cells that are found in fruits and vegetables. And if you think about it, the enzyme pectinase breaks down this cell wall glue as fruits and vegetables ripen. That's where you see that textural change between firm to soft. You see that change of the chemistry of pectin, and it's being broken down. Pectin in general is being derived from an industrial perspective from apple pomace or citrus peels. And so they're taking these otherwise waste products and purifying out the pectin or cell wall glue from this waste stream and turning it into a functional ingredient for food products. Now, this pectin will form gels under the right conditions, and I put an exclamation mark. We'll talk about what are the right conditions for pectins to gel in just a moment. So what is pectin again? It is alpha-1 4-linked D-galacturonic acid. And there's different levels of methylation and acetylation. And so a methyl group is going to esterify, and in some pectins it can be upwards of 70 or 80% methylated groups. And then you can also see acetylation. And again, when you are buying pectin, you will buy it based off of the percent methylation or acetylation in the chains. Sometimes in different forms of pectin as well, you will have those sugar units in the chain substituted with other monosaccharides. So rhamnose, galactose, arabinose, or xylose are commonly found. Again, is there a magic formula to say which type of pectin for which application? Sort of. We'll get to that in a moment. So there's also some other types of pectin. When going out and purchasing pectin, you would be discussing whether you want it to be a rapid set or slow set. So rapid set is going to quickly gel up, whereas slow will take time. Rapid set has the benefit, especially if you have fruits or particles that you want to suspend evenly within your solution. Rapid set is your friend because it's going to help set, and you're not going to have all the fruit settle out at the top of your jam. Whereas slow set gives a better, superior texture, but again, if you have fruit particles or seeds or so on, they are going to deposit out either at the top or the bottom. High methoxy versus low methoxy. We'll talk about the chemistry behind this in a moment, but again, this is the sort of question that you may be asked if you're connecting with a supplier for pectin. Do you want high methoxy, which just is going to set under Brix and sugar and pH conditions, whereas low methoxy doesn't have as quite a strict pH or Brix requirement. Prehydrated pectin's a convenience thing where the pectin's being solubilized in water or another liquid solution prior to receiving, and so it's easy to blend in. Pectin, if you just add it straight into a product, is just going to clump up, and so dispersibility is important. And in other cases, you'll find rapid dispersion pectins where they're adding sugar or maltodextrins to help increase the dispersibility of the pectin. So what are the parameters for setting pectin to get that gel? In the case of high methoxy pectin, where you've got greater than 50% methoxy groups, you need a pH around 3.5, a Brix that's greater than 55%, and you're going to add your pectin at about 0.2 to 0.4%. And high methoxy pectin really needs that combination of pH and Brix to be able to make the gel set. Low methoxy pectin, however, think back to chemistry class where we talked about divalent cation bridging. Calcium, in particular, has 2 positive charges, and low methoxy pectin can be stabilized with the negative charges using calcium or other divalent cations. Calcium is the most common, though. And then the thing is, what's neat is if you have a low methoxy but high amidated pectin, then you really don't need a lot of calcium to get it to set, because the ammonia groups within the pectin, the amidation or ammonia groups are going to provide some of that positive charge, which will help stabilize the pectin itself. So again, we mentioned some of these other pectin types that you, when you're going out and connecting with your supplier, you may be requested prehydrated pectin. And if you add pectin to your jam too late in the process and the Brix is too high, then it will not hydrate, and therefore you will not get gel structure. Prehydrated pectin, this is where you have the pectin and it's mixed in a water solution. This will hydrate it prior to addition. So you can't just add dry pectin into a finished jam unless it has been prehydrated. Blended or rapid dispersion pectins, again, this is where, unless you've got some sort of really high shear dispersion, some sort of blender that's going to mix in that pectin really quick, it's going to just clump into lumps and it's not going to form a strong gel. And so they're using sugars or maltodextrins, again, to help disperse this, so when it's blended into your product, it mixes uniformly and does not clump. Amidated pectin, what's another interesting function of this is that if you heat and cool and heat and cool and you have that thermal cycling in your product, it will reset its gel, and that could be beneficial for products that may be pasteurized or heated under different conditions. So how do we test our gel strength? In the United States, the most common method is the SAG method. You make, in essence, almost this little cup of gel using 65 Brix sugar solution and pH 2.2, and then you measure how much it sags over time. In general, it's over 2 minutes time. And you're measuring it with a penetrometer or a ridge limeter, and this is where you are measuring how far did the gel deform over time. So how tall was it, and then how much did it shrink? You can also do tensile strength, where you make the gel to your set specification. You put a probe inside your gel, and then you use a texture meter, such as the one that we have in the lab downstairs, and you measure the tensile strength. How much force does it take to pull the probe out of the gel? Or you can use a rheometer, so measure viscosity over different time, temperature values, or you can change off your pH or Brix values as well. Design of experiments being critical here, and you know how much I love design of experiments. So where else do you find pectin? In gummy candies. So many of the gummy candies that would otherwise be using pectin, they're using gelatin, are switching to pectin because it's a vegetarian, vegan-friendly product. And so you can get that nice gelling, gumming sort of texture without having an animal product within your candy. Bakery fillings and glazes often are also using pectin. Think about in your baking class, where you're using apricot glaze. You can make other clear glazes using pectin-based solutions. Pectin is also commonly found in yogurts and soured dairy products. So think kefir, or think some of these yogurt tubes where you want a nice mouthfeel. It's also commonly found in juices or smoothies. I've heard about it being used in ketchups, to a lesser degree in bakery products because it's able to retain moisture. So if you have questions, I highly recommend that you connect with some of your suppliers for pectin and have some fun trying out some different pectin formulations in your lab.